way. If not, I can choose one.
No, I have one.
Yes, I'm ready. Perfect. Excellent.
So h of x equals x plus 4 when x is less than 2, and square root x plus 2 when x is greater than or equal to 2.
Perfect. Excellent. So the very first thing we need to do, remember, is the domain, because I need to create my table. The table is mandatory. So this inequality changes into this. Is that okay?
Yes.
Okay. This changes into bracket 2 to infinity. So when I look at these two intervals, I say everything to the left of 2, 2, and everything to the right of 2. So obviously the domain of this function is indeed everything. Is that okay?
Yes.
Perfect. Now, in the table, I always have to have 0. I should strike that. What if the function is defined from 1 to infinity? Then no. But in such situations in which the function is defined on all real numbers, I have to have 0 in the table. And the other very important point, or x value, is 2. Why I need 2 is because at 2, something happens. The function goes to this, from this to this. So it's a major threshold, right? So I need to put these symbols right under 2. Exactly under 2. I have the parenthesis and I have the bracket. What do they signify? Well, this will signify the full point and this will signify the open point. If these two are equal, then the function is continuous. If these two are not equal, then the function will not be continuous. So I know that this is an overkill, but bear with me. Between negative infinity and 2, I will be using this function. Between 2 and infinity, I will be using this function. Just because I don't want to look here, what if I make a mistake? It's right here on top of the interval, so I can't make a mistake now. So I will plug in 0 and I get 4. And I know that x plus 4 crosses the x-axis at negative 4. These are important points. If I can find them, I will always look for the x and y intercepts. But I also have to plug in 2, although I'm not allowed to, because this will be an open point as long as this one is not the same thing. If it's the same thing, this will be a full point. So now on the other side, when I plug in 2 in here, 2 plus 2 is 4, the square root of 4 is 2. So therefore, I know that this function is not continuous because it will have a jump at 2. The limit from the left will be 6. The limit from the right will be 2. I need another point here. So the nicest one will be 7 plus 2 because it's 9. The square root of 9 is 3 because it's an integer. Okay, so that's all I need. These are all the points I need, and now I'm ready to graph the function. Any questions so far? Anyone? Please stop me, interject, ask.
Can you explain how you got the 7 and the 3 again, please?
I picked a number so I can take the square root because I can pick 3. But 3 plus 2 is 5, and the square root of 5 is not an integer.
Okay.
So I jumped to 7 because 7 plus 2 is 9, and the square root of 9 is 3.
Okay.
I need at least one more point on the other side. And I wanted to find something convenient because I don't want to plot 2.399. Okay. So now we're ready to graph the function. And it's a very good point. I was going to choose this type of function anyway, or this type of example, because I still see some of you still graph something like this. Although we said many times that this function exists only between negative infinity and 2. This function exists only between 2 and infinity. There is no such thing. It's not possible. I cannot extend this function to the left because it only exists between 2 and infinity. I cannot extend this function to the right because it only exists between negative infinity and 2. Something like this makes no sense. By the vertical line test, this is not a function. Okay, so negative 4, 0, 0, 4, 2, 6. But it's an open point. You can write on it so you don't make a mistake if you want. So this is an open point. And this is a straight line because it's a linear equation or linear function. I'm done. That's why I'm trying to make a point. You don't have to use colors by any means. But this is this color, and now I'm going to use this color. So 2, 2 is this full point. And it has to be exactly on the one under the other because they both happen at 2. And then 7, 3, 4, 5, 6, 7, 3. This is not a straight line. The square root is not a straight line. If you remember when we graph the square root, it's like this. So I'm going to graph something that does not look like a straight line. If you extend this to this side, if you extend this to that side, it makes no sense. I can't give credit for that. So now if we want to determine the range, this goes on forever. It's an arrow. It goes on forever. And this goes on forever. So for this function, the range is everything. So after you graph something like this, what could I ask? One question would be, is this function continuous at 2? So that's the first question. So I don't know what I was going to write. I just wanted to write continuous. Yeah, I'm going to put the C in front. Okay. Continuous at x equals 2. And you will say no, because the limit as x approaches 2 from the left, I don't even need to look at the graph. The limit from the left is 6, right here, of f of x is 6. And the limit as x approaches 2 from the right of f of x is 2. They are not equal, right? And the function value f of 2 is 2. So they're not equal. So therefore, the function is not continuous at 2. What else can I ask? So I can ask the limits. That's why I already put them in there. 2, can I ask about differentiability? Is this function differentiable? Yes, but not at 2. Not at 2, since it is not continuous. I can still find f prime. Very simple. I'll find f prime here. This is 1. And I'll find f prime here, which is 1 over this 2 the square root of x plus 2. This one for x less than 2, and this one for greater than 2. Because it's not continuous at 2, it's not differentiable at 2. So I can write a derivative. I don't know why I put the 1 so close there. So I can write a derivative, but I will say the derivative does not exist at 2. I cannot put the equal symbol anywhere. Any questions so far, please? Any questions? Any questions? So what if in the same problem, I may also ask you to state the definition of continuity at a point. So definition of continuity at a point. We wrote it. If you remember, it's the limit of f of x as x approaches a from the left must equal the limit of the function as x approaches the same number, of course, from the right, and must equal the function value at that point. Is this clear? Is this clear? How to graph it? And what questions may be asked here? Is this okay? Okay, next question, next topic. Next question, next topic, please. Jesse, is this okay now?
It's a little confusing, but I just think I need more practice. Like,
Oh, when you say confusing, which part is confusing?
so I guess it's just the graph or the table that you use. I'm sorry, because I kind of do it a different way.
I highly recommend get used to it because in the next chapters we're going to use this table a lot.
Okay.
I mean, there is really nothing to it. You just put this point in and you just copy the symbols. There's really nothing to it, I would say. But is it better now?
Yeah, it's better now.
Okay, perfect, perfect. Okay, next question, next topic, please. Anyone, please.
Can we look at some of the graphs with the when to know if it's differential or not?
Yes. Excellent. Let me open. If you have an example for us, I will go directly there.
I do not, sorry, but I know our last homework, we answered one of those questions and I just was
The homework that was due today?
No, the one Tuesday. Let me see if I can pull the question.
Is this the one? 26 on 144?
Yeah.
Perfect. Let's take a look. So I'm going to open the book. I did post these solutions, so they're posted. And of course, I'm going to post the solutions for the last homework before the test. Please don't forget to come to class on Tuesday. And please do not forget to have handy any valid picture ID. Okay. Okay, I'm almost there. And we said page 144. So I'm not sure what's going on. Is it frozen? Okay, no. Okay, it's good. So we won 144. And that was 26. Okay, so the function when it's not continuous cannot be differentiable. Here I can draw a tangent line, so it's definitely differentiable. Here I cannot draw a tangent line, so there is a vertical tangent here. So this is a cusp or a corner, so the function is not differentiable here. Here it is differentiable, the tangent is horizontal. Here it's not continuous, so then the function cannot be differentiable. Here it has a corner, it has two tangents, one tangent from here and one from here. That's not acceptable. So at this point, it's a corner, it's not differentiable. This is another corner, not differentiable. And this is a vertical tangent, not differentiable. Here, it's perfectly differentiable because I can draw one tangent very easily. Is this okay?
It's a little more clear.
Okay, so not continuous, corner or cusp, corner or cusp, corner or cusp, vertical tangent, and not continuous. Where I can draw one tangent, it's differentiable. It has to be continuous.
So if I see two tangents, it's just not
No.
differentiable.
Any cusp, like between two teeth, and any corner, it has two tangents. Tangent, 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 or vertical, so to speak. But here I can draw one tangent. Here I can draw one tangent, and here I can draw one tangent. Perfect. Good. Next question, next topic. I was hoping that we would do as much as possible. Is everything clear? We don't need to review anything?
I struggled a lot on the quotient rule and the chain rule.
Absolutely, of course. So these are differentiation rules, of course. Absolutely. Yes. If you have anything for us, we'll work on those problems. If not, we'll find other problems. Anything.
So our homework we did and turned in today.
Yes, I'm ready. I didn't write the solutions yet.
Okay, let me find the one that gave me the most trouble.
Yeah. Do you want me to, if you have the number, I have the book right here, so it's easier for me to flip the page to what you need. Is it 1.7?
22.
Yep, 22 in 1.6.
Yes.
Okay, 22, 22, 22. The one with g of x?
I wrote it as f of x and then x third square root.
So it's 1.7 then.
Oh, sorry.
No, it's okay. So x cubed?
Yes.
Okay, perfect. So 22, and this is on page 171. And this is f of x equals x to the third multiplied by the square root of 5x plus 2. Is this the one? Yes?
Yes.
Perfect. So we want to find the derivative. I notice, first of all, that this is a product. So this will be my function 1, and this will be my function 2. So I have to use the product rule. So the first function prime, 3x squared, times the second one, plus the first function times the second one prime. It's the square root. It's 1 over 2, the square root of 5x plus 2, times the inner function prime, multiplied by 5. You can leave it as is. I'm fine with that. Or you can find the least common denominator, which is only 1, to the square root of 5x plus 2. Multiply this by 2 to the square root of 5x plus 2. And you have 6x squared times 5x plus 2 plus x to the third times 5. I'll put it in front. And we can simplify it. So 30. I'm just checking that. Okay, so I have 30x squared plus, 30x cubed plus 12x squared plus 5x cubed over 2 the square root of 5x plus 2. Combine like terms, and finally I have 35x to the third plus 12x squared over 2 the square root of 5x plus 2. So again, yes,
So for where you were writing at f1 of x, wouldn't that be
you mean f prime.
f prime? Sorry,
That's okay.
wouldn't that be 6x instead of 6x squared, or why did it turn to square?
So when I differentiated x cubed, you mean?
No. So it goes to 3x squared, and then when you brought it back down, where it says 6x squared times 5x
Yes,
plus.
because I found the least common denominator. The least common denominator is 2 the square root of 5x plus 2. This one is 1. So I need to multiply this product by 2 the square root of 5x plus 2. So when I multiply these two, I get 5x plus 2. When I multiply these two, I get 6x squared.
Okay.
That's okay. I'd rather check. Plus 5x cubed. And then I distribute it. So it's 30x cubed, 12x squared, plus 5x cubed. These are like terms. So then I have 35x cubed plus 12x squared. Katie, is this okay? Is it clear now?
I think I'm confused on how you're setting it up in the beginning.
You mean the product rule?
Yeah, and then I ended up doing the 5x plus 2 to the 1/2 exponent instead of keeping it in the square root.
This is what I said. It's up to you. It's a waste of time.
Okay.
It's a total waste of time, and it's cumbersome for the square root. For any other index, yes. But for the square root, so the way I present the product rule is 1, 2, 1, 2, 1, 2. 1, 2 prime. 1 prime times 2 plus 1 times 2 prime. You can use any method you like. I just like, for me, I got used to this. You develop your own style. I'll accept any. You can twist this, you can twist this, you can twist this. It's up to you. But for me, it makes sense 1, 2, 1, 2, 1, 2. But again, I accept other methods. Now, when it comes to the square root, I said this is the only one I don't recommend. Please don't change it into a power. This is 4 actually. So we know that the square root of x prime is 1 over 2 the square root of x. Don't look into it more than that. This is the simplest thing. So therefore, when I differentiate the function, and we wrote these formulas last time. So just for simplification, I gave you that because if you change the square root of x, if it's confusing to you, change it. That's fine. So I remember we wrote it, but I don't want to waste your time. Anyway, so this is the same thing. 1 over 2 the square root of f times f prime. So this should be times x prime, but there is no need because this is 1. It's the same formula. So this is the only one I highly recommend. Don't waste your time. It's too easy. And then you change it into a negative power, and then I have to come back and write it as a fraction. There is no need for the square root. Of course, I accept the negative power, and then you have to change it, but this is the easiest. But if I have the cube root, it's a different story. Yes. If I have the fifth root, yes. But if I have the square root, it's too easy, and it's a waste of time. This is just my opinion.